Okay, started.
Perfect. All right. Good morning, everyone. So today I want to quickly go over what's been happening in terms of development. I want to go over what our goals are right now, and also continue the discussion we left off last week. So, in terms of current priorities, things haven't changed. We want to do the demo. We uh, we want to get through the API review and aim for alpha after that. So, in terms of the demo, so we have a few things that we need to complete, which is development, deployment, and testing and documentation. So what we said for the demo was the code that we show in the demo is going to be working code, and it's going to be done in such a way that people can really start using it, um, where it's documented, it's well tested, and it deploys right every time, um, and close to production quality as much as possible. So at some point earlier this year, we did have things working, but since then we've been making changes to the spec and the API, the gRPC spec and the Kubernetes CRD API. Um, so so we've had to go back and make some changes to our code. Uh, I'm happy to say this week we've made good progress on that. If Krish is on this call, he's been moving the different components to start using the new API and the new spec. So we're definitely on track to do the demo sometime in the next few weeks. In terms of deployment, we've got all the different components deployable using a customized templates, and that is in a pretty good shape. The only thing that we need to work on there is having a different deployment step for sample provisioner and the sidecar. Right now, they both deploy as one, and that's a function of the fact that we want to run those two as two containers in the same pod. Even though technically it doesn't have to be, things can be over the network, and the gRPC calls will just work fine. But that's just how it is today. So that's one tiny change that needs to go into the deployment of the sidecar, and then we should be good to go. In terms of testing, end-to-end tests are one of the things that's missing. One of the major things that's missing. But otherwise, we're in a good shape. We have unit tests. We have uh, uh, um, functional tests. Mocked out clients and tests of different functions of all the three components. We're also well underway with the documentation effort. We have decent docs right now, which talks about what the different projects are for, how they integrate, and there's still more to do on that. I think Tejas here is currently working on documentation for how to write a cozy driver. Hey, Tejas?
Yes, that's correct.
Okay. So, okay, given that this is the set of priorities, I'd like to get your info on where we are in terms of these different tasks. So let me start by asking Krish uh, where he is in terms of moving the different components to use the new API. Krish?
Yeah, so the sidecar is now at a point where uh, like all the versioned for all the version dependencies for the API and spec are updated.
Mhm,
Everything is compiling. There's just some minor test issues on Prow.
mhm.
Um, and so the next step will just be adding in, the new functionality around. Um, Let me check my notes. I think there was something we wanted to change with a health check, as well as some changes to reflect. Give me a second. Yeah, I think we still just need to, in general, make some more changes to the sidecar to reflect the spec, I believe.
Okay. All right. So you're getting into the sidecar now.
Mhm.
All right. Sounds good, Krish. And I think Tejas is the other person that's working on something here. Tejas, how's the progress on that documentation?
So it's going well. So I'm looking at the documentation. I also looked at Chris's PR on the changes he's doing,
Hmm.
um, with the spec updates and whatnot. So I'm kind of incorporating that as well.
Hmm. Okay, sounds good.
Yeah.
Yeah. And other than that, I've been talking to everyone here about reviewing the controller and seeing if there are any race conditions and making sure that it works as expected. Anyways, I got a chance to do that yesterday, and I have there were no race conditions, so that was good. Um, and I've added some new functionality in there. So, for instance, I've added exponential back off in case of errors, in case of retries. Um, and it's an open PR right now in the API repository. Um, um, Anyone here, if they're interested, please go take a look at that PR. Um, yeah, to see how the controller logic is implemented. All right, so this was in terms of our development milestone. Now let's actually get into. Oh no, let's actually go back and talk about where we continue where we left off last week. So where we left off last week, we were looking at the API uh, um, repo. We were talking about what fields should be left in there, what fields can be removed. And one of the things we agreed on was that we can remove this version field from protocol. Um, so that change is yet to be carried out, but this field essentially today doesn't serve any purpose, given that every different provider like S3, Azure, and GCS, every one of them can represent the API in their own way. So it makes more sense to have a version that's specific to a provider inside of the provider specific struct. Um, so that was one of the things we decided on. Um, and then we were so I have another question that I want to ask here, and then we can go into bucket mutation and the approach that Tim was mentioning. So in terms of protocol, currently inside of the bucket object, we have where is this? Yeah. So inside of the bucket object, we have protocol as a struct in there. Some fields in the protocol are filled back by the sidecar once, say, the bucket is provisioned. And I think we spoke about this a few weeks back, where we said the endpoint is something that only the provisioner can know, and this endpoint being the endpoint, the unique endpoint to access the bucket itself. So if the endpoint information is coming back from the uh, driver, so it causes a small confusion here because protocol has the endpoint field, and this is in the spec. So going and filling the spec field back in response to a successful creation of a bucket, just seems it's not idiomatic.
Wait, I don't. Is this something new, or this been this way always?
Well, I'm asking a question. So so
Yeah, everything in the S3 protocol field must be filled in by the
user or
by the
from mhm,
no
admin.
by the plugin. The plugin has to fill in all of those things.
Then is it okay to have it in the spec? I know what you mean when you say it has to be
Yeah,
filled by the plugin, but is it okay to
yeah,
say
but
that in the spec?
because it's the spec of the bucket object, not the bucket request. It would be weird if we were modifying the spec of the bucket request,
Mm-hmm.
other than maybe to perform the two-way binding. I mean, we do this with PVCs, and it's weird there.
Mm-hmm.
But because we are creating the bucket, in response to the bucket request, we wouldn't, well, let me think about this. No, we do create the object first, and then the sidecar modifies it.
Mhm.
And yeah, I think the key is you would want your admission controller to implement some like set once kind of semantics, so that like if it's blank, you can set it, but once it's been set, you can't change it, which is a common semantic in Kubernetes APIs, where some fields can be modified if they're blank, but once you modify them, that they're set in stone.
Yeah.
So I think that's how this one would be treated. Is of course all of these would come from the plugin, and it's okay to put them in the spec as long as the admission controller enforces a set once kind of a semantic, so that you can't just go and edit them all the time.
All right. So how does the user specify what region they want to provision the bucket in?
They don't. I think the key is they don't have to, right? If they want to, they can specify something in the bucket class which would perform a hint or a filter or a recommendation or whatever to the plugin. But if the plugin, if they don't care, the plugin should pick one and tell you where to put it.
That's true. That's true. Yes. Okay. So the semantics will look like this. If it's filled in, we use that. If not, we fill it back in. The driver would fill it back in. So
But
go ahead.
you're saying that the controller that creates the bucket would copy it from
Bucket class.
somewhere to the bucket object and then invoke the plugin, and then the plugin could why not? I mean, so presuming you have an admission controller that implements the set once semantics, then you can't set it more than once. So what you want to do is leave it blank. When you invoke the sidecar, where the sidecar calls the controller, it will go read the bucket class and obtain whatever region parameters or whatever was in the bucket class and pass those in at the time that it invokes the plugin. And then whatever the plugin returns, that's what you stamp onto the bucket object. But the
That's
initial
fine.
creation of the bucket doesn't need to say anything.
Yeah, that's fine. That's not a problem. Yeah. It's just that's an implementation detail. Yeah.
Right, but I think it's desirable to have a set once semantic on the protocol field.
Right. That makes sense too.
Yeah. Okay.
Yeah. So yeah, that way we just don't fill it until the driver responds.
Yeah. Yeah, and the sidecar can just pull it out of the bucket class and pass it down to the driver if the user specified anything.
Got it. Yeah, that would work. So we are filling back in the spec, and I think that's okay now. All right. So
and didn't we talk about also removing the name field from the protocol struct and making it implicit?
Right. Yes. I think Blaine brought it up, and yes, we thought that was a good idea. Yes. So the name and version both are going away.
Yeah, and I just wanted to mention that, like, I was looking at how similar things are done in the Kubernetes API, and unfortunately, there's no magic command that does a discriminated union. Like, you basically have to have your admission controller, go through all of the elements of the union and make sure they're all null except for one. And if two of them are set, it needs to throw an error. So it's just Golang code that enforces that.
Yeah, and Krish is adding validation for that. So do we already have that, Krish?
No. For the protocol name?
Yeah, we're getting rid of protocol name and protocol version. So yeah, so that validation was based on the protocol name before, but given that.
So what it needs to be now is it needs to look at S3 protocol and Azure protocol and GCS protocol and make sure that only one of them is non-nil. Or zero. It's okay for all of them to be nil if it's not set yet. Well, maybe the protocol itself is nil in that case. So then you would always expect exactly one to be set. Yeah. You just need a bunch of Golang code that looks at all the pointers.
Yeah.
Yeah. It'll make the code a little less pretty, but it should be reasonable to add.
Yeah, it certainly looks ugly when this is done in Kubernetes.
Yeah.
It would be nice if there was like a magic validator that could just, say only one field can be non-nil and you run that validator.
Yeah. I mean, yeah. I think it's too much work to actually add that validator right now. Like we could do something with struct tags, but again, I don't know if it's worth it. It's not worth it. All right, so let's go to the topic where we finally left off last week. And so Ben, I sent you some links to the proposal for network gateway. Did you get a chance to look at them?
Oh, did I see those links?
Oh, I sent it on Slack.
I might have missed these.
Oh, it's
In which
okay.
case I apologize.
Oh, no problem at all.
Oh
So
no, that's right. That's right. You did. Okay, you sent them to me on Thursday, and I was in the middle of something, and I did not click on them. So this is totally my fault.
not a big deal. It's okay. So let's actually the reason I brought it up was we were having a conversation about uh, uh, um, bucket mutation, and so as of right now, we have an approach where uh, we can allow bucket mutation, if needed in the future, and the way we're going to do it is by adding a new field called bucket mutation policy inside of the bucket, and the admin can go and make changes to buckets that have bucket mutation policy set to allow. Um, so that's our current story. There was another concept. Good.
But I was going to say the feedback from Tim was a little bit more complicated than that. It wasn't only about mutation. It was about this whole concept of doing the namespace object bound to the non-namespace object,
Right.
Which was something that he didn't like, especially when it comes to, even if we don't allow mutation, the mere sharing across namespaces gets funky. And I thought I felt like that's what he was objecting to more than the how do you do mutation.
Right. I was yeah, and along with that, the self-service. So yeah, I was just about to get to that.
Okay.
So
Okay.
yeah, you're right. Um, so we were exploring this other approach where we said we just wanted to explore it. We don't think it's unless it makes a huge difference to in terms of benefits. um, we said that it might not be we need to justify the effort that it's going to take, because if we do go down that route, everything else has to be reinvented, everything else has to be reasoned about. But we also said that we'll go through this exercise once to see if that approach that Tim brought up would work. And then Jeff also mentioned to me that he had a potential solution. So I'd like to listen to that also. So first I'll start by just refreshing what that approach was that we discussed, or what that approach was that we think Tim was referring to. So Tim was talking about network gateways, where a network gateway can be managed within an organization by either a core infrastructure team that decides how the network is going to behave at an organization level. So, say at Google, a core infrastructure team would define the rules for top level assets like Google Search or Google Calendar or other Google assets. And per team, they might have their own rules that the infrastructure team wouldn't necessarily know. And uh, in that case, the way network gateway, if I understand correctly, the way it is designed is you have the concept of uh, say just like role bindings and cluster role bindings, you have namespaced objects and you have non-namespaced objects. They both behave symmetrically. What that means is the namespace object binds to the namespaced version of, so a namespace bucket request would bind to a namespaced bucket, and similarly a non-namespaced bucket request would bind to a non-namespaced bucket. And this is the approach that Tim or I understood from what Tim suggested. And we were just beginning the exercise of how that would work and if that would work for us. Does it ring a bell for anyone?
Hey, Sid, I haven't read those documents ahead and I was just checking it. So I see that they have some gateways, HTTP route. The gateway, what you mean? It can be either namespaced or non-namespaced?
Right. So there is one like just like cluster roles and just roles, or role bindings and cluster role bindings. One is at the non-namespace level. One is per namespace. So one of the things we said about network gateway was, it is different from buckets, in the sense that if I had two different, so in case of buckets, if I wanted to, we have this concept of sharing in buckets. That is, if I create a bucket in one namespace and say I want to bring that bucket to or have that bucket be available in a different namespace, you'll have to share the bucket. In case of network gateways, if there's no concept of sharing. You can have two different network gateways each in their own namespaces, and have them be exactly the same set of rules, but they're still not the same. There's no sharing involved in there, which is unlike buckets. So one of the things we said was, network gateway analogy might not exactly fit well here. All right, so that was kind of where we were last week.
Yeah, and the other use case that we can use as a comparison is what we did with volume snapshots, where we did go down this path of a namespaced object bound to a non-namespaced object. And if you wanted to share it across namespaces, currently the only way to do that is to make a copy of the volume snapshot and the volume snapshot content and bind them. And that's how it works today. I thought about what would happen if you took the network gateway model and applied it to snapshots and had a concept of like a cluster-wide snapshot that anybody could use, and it doesn't make a lot of sense when you think about it for snapshots.
I don't think it's even possible you generate something that can be either namespace or
no, it's a separate object.
So I'm just looking at this diagram. I mean, can I share for a minute? Can I share for a minute?
Oh, please, yes.
I think if you stop sharing. I'm just okay, how do I? Okay, here. Okay, so if you look at here, right, share some examples. This is still a namespace, right? It's not really like cluster space, right? So this gateway, if you look at the one on the left, shared, but this still has a namespace. So meaning it is still, it's not like the class. It also has a gateway class, which it says that's a cluster scope, but it didn't say gateway is also like a cluster scope, right? So looks like it just, you still have to specify namespace, but this can be shared by two or multiple namespaces, or this one is the just used by one, but they have to be same. Looks like this. So yeah.
So then buckets are always, so in this analogy, if we were to apply this to buckets would always be namespace, and bucket access would be able to point to buckets in a different namespace. Is that?
The question is, the question is whether there's a non-namespaced component or not.
Too many. Oh, okay, interesting. It also talks about many to one. What does that one? All right, so he shows a one to many and one to one, but it says there's also many to one. How does that work? Oh, okay, so it basically says the route like this, it can also point to some other gateway. Okay, I see. All right, it's kind of messy. Okay. Yeah,
Yes.
so this one is pretty complicated. So it has like, yeah, it can also, this route can also go here. It can also be, going this way as well. Yeah. So yeah, so 3.
If a bucket is in a different namespace, then a namespace using it, I mean, we had this conversation. We said buckets have to be cluster scope because we'll have no control over a bucket from a different namespace. We won't even know if it's still alive or just usable, and discovery is also not easy. Is that still the case?
I was just trying to understand this model. I haven't really thought about like how does that apply to the bucket and the bucket request yet.
Yeah. I was just
and also this is a little bit like this other way, right? So this is like what the gateway would be the bucket then, and then the request would be under, right?
bucket access.
Yes.
Yeah.
Okay.
So I haven't read this, Xing, but maybe this is interesting. We did for a little bit consider that a bucket could live in the provisioner's namespace. Provisioners are namespaced, and that's where the plugin and sidecar run. And a bucket instance could be namespaced, and the namespace is the same namespace as the provisioner. But for simplicity and possibly to mimic the PV-PVC model more closely, and possibly related to easier sharing, we thought the bucket should be cluster wide. But we did think about it where it could be a namespaced resource living with the provisioner.
Okay, yeah, I just want to show the things. This is the example that the team wants us to take a look. So
right.
All right.
Any thoughts on this, Ben or anyone else?
I guess I should have read their design in detail to understand what they're actually doing, because it's not what I had presumed, and I haven't. If it is truly novel, something that we haven't seen before, then yeah, I want to understand all of the implications, including like do they have 2 objects or do they have 1 object? Is there a binding semantic? Obviously the cross namespace pointers is something that you can understand. But where that gets complicated is when you have the binding. If we found a way to do this that didn't involve the binding 2 objects together, then maybe like doing it cross namespace would introduce way less issues, or having many-to-one relationships or one-to-many relationships or many-to-many relationships, or which I hope it doesn't make any sense in this context. But yeah, I'm gonna have to. I mean, this would be an even bigger change than what we have been contemplating. Like I had just been thinking about a relatively simple, just duplicate all of the bucket objects that we have in a clustered version, and then allow BARs to refer to clustered ones as well. But if that's not what the proposal is, then yeah, I'll have to go back to the drawing board.
Yeah. Yeah. So in this case, there wouldn't be a concept of a copy at all, and mutation would only be allowed from, or just bucket operations would only be allowed from the namespace in which it was provisioned.
And I like the idea of not a copy or a clone.
Yeah, me too.
Sid, do you think it would be a time I could bring up the diagram?
Yeah, please. Yeah. So Jeff also had a proposal. Jeff, please.
Well, let me. I'm going to try to share my screen here. All these different Zoom-like things, I get them mixed up. Hold on. I'm trying to find out where I can share screen. There it is. I have to be allowed to do that, Sid, it looks like.
Oh, Xing can make you the host. Let me see if
okay. Let me, I can do that, I think. Let me.
I'm going to do this, and now let me try it again.
Okay, now you should be able to share
Okay,
now.
thanks. Share screen. Desktop. Okay, I clicked share. Okay, do you see a diagram?
Yeah.
Okay, great, thanks. Good to know. Okay, so on the, this is just an idea of trying to get, I was just thinking a little bit of how to get rid of cloning and make it a little simpler for the admin, and maybe a more accurate abstraction of a bucket instance mapping to a single backend bucket. In other words, not many bucket instances mapping to the same backend bucket, but just one Kubernetes bucket instance mapping to the backend bucket. So those were my thoughts. On the left side of this diagram is what we have today, essentially. Within the same namespace, multiple BARs can point to a single BR. You get multiple BAs as a result of those multiple BARs, and they point to a bucket. And okay, so that's today. But today, when you try to say BAR3 in namespace 2, then it gets complicated today. Today, you have to create a BR3, and there's a cloning of a bucket instance and so forth. And what this idea is that the BAR3 shown there in namespace 2, where we're now talking about sharing a bucket, it's actually green-brown sharing. That BAR3 points to the same bucket. There's a BA3, as you would expect. That's no different. But the difference is really twofold. There's only one bucket instance per backend bucket. And number two, BARs in brownfield uses, they point to the B instead of a BR. So in namespace 2, you don't need a BR anymore because you're just sharing. You're not requesting anything new. And you still have the complexity of the admin having to tell a user what the name of the B is. But in today's KEP, the admin has to tell the BR author the name of the B. So that hasn't really changed. Instead of the name of the B being in a BR for brownfield, the name of the B is in the BAR. The communication, difficulty that might exist in that is the same between both ideas. Anyway, that's a diagram of it. There's some.
What are the benefits of this, Jeff? What are the benefits of this approach?
Well, thank you.
The benefits obvious that there's no B2 or B3. There's just
one.
Right.
There's just
Right.
B1. What I'm wondering is what if namespace 1 goes away and you want to keep using the bucket?
Let me think. Namespace 1 goes away. Okay, so everything on the left is gone now.
Right, but presumably the deletion of BR1 results in the deletion of bucket 1, and that's not what you.
But it wouldn't in my case. In this case, it wouldn't, Ben, because really you wouldn't delete a B until all accesses were gone.
But how would you know that?
Well, we have a list of accessors from BA to BA already, and also Ben, in the current model, the bucket can be pulled out from underneath. How is that different from doing that? The scenario that you just asked about.
Right.
Well, it can always be pulled out from underneath because somebody can always just go to the back end and delete it. The point is there's an orderly way of doing it, and there's an orderly way of avoiding it when you want to avoid it. And what I'm trying to figure out here is clearly if you want it to go away, you just delete it. No big deal. But if you want it to not go away, how do you make sure that happens?
Yeah, so we do have a list of accessors, but there's another problem here too, which is since the BAR points to B, the BAR would have to know the name of the B before it's created.
Yes, but that's not any different than the BR in brownfield needing to know the name of the B.
You presumably choose it ahead of time.
Today in brownfield, In namespace 2, if I were to draw what we do today, in namespace 2, I would have a BR3, which has the name of B, and I'd have BR3, BAR3 pointing to BR3. That's it. But BR3 still needed to know the name. And now I'm just saying BAR3 needs to know the name, but that complexity is the same between both ideas.
Yeah. So this is really yeah. I'm thinking through all the different trade-offs. Yeah, we do have that benefit of never having to copy, and I really like that, to be honest. So BAR1 would point to BA1. How would that work? Like, what would the user experience be like? Say a user wants to create a bucket and utilize it.
Are you asking me, Sid?
Yeah.
You're talking about green to brown.
Yeah, no, greenfield creation, a simple use case. So what would that YAML file contain? Would the YAML file contain a BR and a BAR, and then a pod, pointing to the BAR?
Yeah, so you have your BR as normal, just points to a BC. You have a BAR pointing to your BR, and that's it. That's the user side of it.
All right. How does the BA1 and BA2 get created in the? Oh yeah, that's the usual step. Yeah, that's the normal.
Cozy creates them.
Yeah, that's true. All right, that's yeah. Yeah, this is why I liked this proposal last time. Also, you brought it up. There was some issue that we had. I'm trying to remember what there was, or maybe I explained it wrong last time. Maybe that's what the issue is. Is that right? So last time I brought it up.
I think I missed that meeting where you explained it some.
All right. Okay. Anyways.
So I still haven't gotten an answer to my question, which is when the guy who created the bucket goes away because, I don't know, you don't need that namespace anymore. Can I unhook BR1 from bucket 1 in such a way that all the other namespaces that are sharing it can continue to use it, but somebody still retains the ability to delete it afterwards?
Yeah, I think so, Ben. I mean, it's a good question, but I believe that bucket 1, as long as BA3, so let's say you get rid of the whole left side of that picture, right?
Yeah.
And all that's left is namespace 2, bucket 1, and BA3, right? And the, so there's still a link between BA3 and bucket 1.
But we don't want that to be the only thing keeping bucket 1 alive, because otherwise the deletion of BIR3 would cause the bucket to vaporize, and that's not, deleting a BAR is not supposed to delete any data.
Well, there's that, and also it becomes a dangling bucket, like there's no reference to it. Is it so
that's the thing that irritates me about the design is somebody has to have control over it.
Right, but is it so bad to say that the namespace can't go away if the BR has created a B?
Well, I don't know, but
yeah, I mean, you can't delete a namespace till all the objects are gone.
Right. So BR will have a finalizer.
But there's the
workflow. What I'm saying is the user would just delete the BR if they wanted to delete the namespace. And how can they do that and not delete the bucket?
So we will know the bucket is being used by someone else, so the BR doesn't get deleted.
Right, but then when does it get deleted?
So deletion timestamp gets set as soon as the user calls delete on it. It just doesn't go through until everyone stops using it.
Right. But I'm saying, what if I don't want to delete it? I want it to hang around for a long time, because this is the green to brown use case, right? I created it inside Kubernetes, and I say, oh wait, I don't want this to go away when I delete my BR, because I realize now that this bucket is valuable to me, so I want to keep it alive.
What's your retention policy?
Go ahead, Jeff.
What's the retention policy? Is it delete or is it retain?
Right, I was going to come to that.
Presumably it would be delete, and then if the answer is I just change it to retain and then delete the BR and it hangs around, then I think that answers my question. Then the only other question would be, like, can an admin then delete B1 later on and results in the actual bucket going away? Is that what would happen?
Oh, you mean if it's retained?
Yeah. So presumably it defaults to delete because that normal greenfield bucket should be deleted
No,
when.
it defaults to, well, does it default? I thought it defaulted in the kept it. It says it defaults to retain.
Oh, well, okay,
Yeah,
but that's a design decision. I would assume it would default to delete because otherwise you're going to leak every single bucket you create, and that's not a good situation.
Yeah, so normally for dynamic provisioning, default is delete.
I know that. I know PVs in dynamic default to delete. We can change it, but that's what the kept says right now.
Okay, well, if I have a bucket class that sets it to delete, and then I create the bucket, presuming the normal greenfield workflow, and then I change my mind and say, wait, I actually want to keep this one around for a long time because I've shoved a bunch of really important data in it.
Yep.
I can go change that deletion policy to retain, and then delete my BR, and then the cozy controller will just let the BR go and leave B1 dangling, right? Like,
yes, just like a dangling PV.
Well, PVs are a little funny. I don't know if they're a good comparison, but then the question is, when I actually, if an admin or somebody who has delete access to the non-namespace object deletes B1, will that delete the bucket in reality? Because somebody still needs to have
that should
the
be
ability
depending
to
on the
delete the bucket.
policy, right? If the policy says delete, then that delete. If it says retain, actually, the bucket, the real bucket should not be deleted.
I thought that the policy affected what happens when the namespaced object gets deleted.
It's on the bucket itself. And
I know it's on the
actual bucket. So we, Jeff and I were having this conversation earlier too. In case of PV and PVCs, if the PVC is deleted and say the PV has the policy set to retain, the PV still goes away. It's just the data in the backend never goes away.
Right. That is how PVs work, but that's not what we want here, right? If you retain it, you don't want the bucket to go away. You need it to hang around. So I was thinking a better model would be the snapshot model. Snapshots also have deletion policies, and they're on the non-namespaced volume snapshot content object. And the way I think it works is if you set the deletion policy to retain and then go delete your snapshot, the namespaced snapshot goes away, and the unnamespaced volume snapshot content just sits there. And nothing happens to it.
Same thing with the PVPVC, but I think PVPVC has I think it's a bug, but they were telling me that's a design, but depending on which one you try to delete first, it behaves differently. That's the bug that we opened actually. But if you delete it in the correct order, if it's dynamic provisioning earlier, you try to delete PVC first, then that's actually fine. Basically works the same way. If it's retained, then it actually still, it keeps the PV, but then if you go delete the PV again, everything will be deleted, including the underlying volume.
You're saying that.
But if you try to delete PV first, then you will have this bizarre behavior. That does not matter what your policy is.
But how is it with snapshots? If I delete
snapshots, different. Snapshots actually different. We always respect the retain policy.
So you're saying if the deletion policy is retain, and I've already deleted the volume snapshot, and now I'm trying to delete the volume snapshot content as an administrator.
Your snapshot on your storage system will not be deleted.
So it will just delete the Kubernetes object, and the sidecar will do nothing.
Yeah.
Okay. So what you could do then is you could change it to the deletion policy to retain while you delete the bucket request, and then the bucket will remain, and that allows you to tear down the whole namespace while other namespaces continue to use this bucket. And then later, if you actually wanted to delete the bucket, you could just set the deletion policy back to delete and then delete the bucket. And in that case, the sidecar could be expected to really delete the bucket at that point. Is that?
Yeah.
Okay.
Yeah, if it follows the snapshot model, yes.
So, yeah, I guess given that, I don't see any huge problems here. It just feels a little bit less self-service, because I guess every BAR you create, you have to know the name of the non-namespaced object. In the old model, there'd be a one-time operation to create a BR in the other namespace, and then all the other objects in the namespace would just refer to that. So once the initial object had been created in the other namespace, you wouldn't need to know anything special.
Yeah,
This
so
way you need to,
difference, it sounds like, let's say in namespace 2, I want BAR 3, 4, and 5.
yeah,
So one of those needs to point to bucket -1. In the
all of them do.
yes.
Yeah, so
And
every time you create a
exception-
BAR, you have to know the non-namespaced object name.
right, for every BAR that
Yeah.
is that's not pointing to a BR. So every BAR in a namespace other than the originating BR, right?
Okay, so the only grossness that this introduces into the design is now BARs combined to two different things.
Well, they're just granting access to a bucket.
Yeah, I'm not saying like this is a big problem. I'm just saying like it's additional complexity that wasn't in the original design. Originally, BARs always binded to BRs, and so you just have one field, you know what it is, validation is easy.
Yes.
Now we're going to have two fields, and validation is going to be a little bit more complicated because you're
Fair
going to have
point.
to.
Right. You can't say a BAR always points to a BR in
Right,
this idea. That's right.
And presumably you actually have like a bucket request field and a bucket field, and only one of them can be filled in.
Correct.
And then so the validation has to enforce that, and then assuming you have an additional level of validation that makes sure that the thing that you point to is actually there, you got to go look in the appropriate place and
yeah, I agree
do
with that.
something
You would want
to
that type of validation would make sense to me.
yeah. Although I don't know if you'd want that to be synchronous validation or asynchronous validation, because sometimes it's okay to create a BAR that points at something that doesn't exist yet, as long as the something will be created eventually.
Right. On the plus side, in this example where there's 3 accesses to the same backend bucket, what you save is you're saving another BR doesn't need to exist, and you don't have any clones of bucket 1. So you're saving 2 additional copies of bucket 1.
Yeah. No, I there's a lot to like here. I'm still wondering, like, can another namespace adopt the bucket in such like let's say we implemented mutability at some point in the future where you could make changes to BR1 that would result in B1 also changing and the sidecar doing some work to enforce the change. Like then if you wanted to tear down namespace 1, is there a way to adopt BR1 into another namespace? Presumably by just deleting BR1 and creating a new BR1 in another namespace and forcing it to bind to bucket 1.
Yeah, that's interesting. I hadn't thought of that.
Like, so you could maintain the one-to-one binding,
yes,
as long as the thing you were trying to adopt was an orphan at the time you were trying to adopt it.
It sounds like you're saying, Ben, is that as long as bucket 1 exists, you would like and bucket 1 was originally Greenfield, so it was created by through Cozy.
I don't think it matters.
Exists, you would.
I don't think it. I mean, I think that we could implement it in such a way that it doesn't matter where it came from. That if nobody owns it, you
always want a BR pointing to a bucket instance. You don't want the idea of a bucket instance that has no BR pointing to it, right?
No, I'm saying it's okay if 0 things point to it, but if I want to make something point to it so that a user can mutate it or do whatever else you want to be able to do, it should be okay to have exactly one thing pointing to it. We just wouldn't allow 2 or 3 or 4 things to point to it. It's 0 or 1.
I see.
And
the reason you're liking the idea of always having a BR point to bucket 1 in this diagram is for the eventuality of mutation, that you would think we'd be doing mutation. A user could mutate for self-service. A user would mutate something in BR, something that's not there now, but something added to a BR later on. A user would mutate that and it would be reflected in bucket 1. Is that what you're thinking?
Or even self-service deletion, right? That would be the other use case. Just if namespace 1 goes away and now namespace 2 is the only guy who cares about this bucket, why not give him the ability to do self-service deletion? If it's just, I'm not saying like we should bend over backwards for this use case. I'm just trying to think through, is it possible to just construct an object and force it to bind in such a way that now namespace 2 owns the bucket and has the only BR that points to it?
What if there was what if there was namespace 3 and BAR-4 in namespace 3? Who gets it if namespace 1 goes away? In other words, just clone the right-hand side, clone it and make another copy of it out there to the right of it. Who gets BR1?
Whoever wants to.
What if both want it? I don't know. It seems like
Yeah. No, you would have a race, and one guy would win the race and one guy would lose the race, and which is how it works with PVCs, right? Two PVCs can race to bind to a PV, and whoever wins gets it, and that's fine. So, and if there's a true conflict, an admin can step in and clean up the mess, right? If you actually imagine two adversarial users who both want to own the bucket, someone has to resolve that dispute. That's got to be the admin. But implementation wise, if an unbound bucket could just get claimed by the first BR to point to it, unless we wanted,
that's a possibility. Yep.
Unless maybe you wanted to have a way to disable that and say this is an unbindable bucket because for security reasons, you might want to be able to create a bucket in such a way that no BR can ever bind to it, for a true brownfield kind of a use case where you really don't want anyone to be able to delete it through Kubernetes or mutate it through Kubernetes.
What I'd like your thoughts on, Ben, is if you look at the diagram as it is right now, and we got rid of namespace 1, like you said. So everything in namespace 1 is gone. BA1, BA2 are also gone. But everything on the right side, including bucket 1, still exists. Is that what you would expect to happen? Or would you expect bucket 1, assume retention policy of delete? Would you expect bucket 1 to be gone if namespace 1 is gone?
Oh, I would expect it to be gone. Yeah, if the retention policy is delete, or the deletion policy, I thought we called it, then the deletion of BR1 should result in the deletion of the bucket, because that's what the policy says.
Even though BAR3 is pointing to it.
Yeah, because it's not his data, right? It's namespace 1's data. Until you change that retention policy, namespace 1 has the keys. He gets to do what he wants.
So that's a good, that I'd be interested in other, I mean, there's logic behind what you said, Ben, and I wonder what other people also, what they're thinking of that scenario.
I mean, if you think of the converse is nonsensical, because if by some means you keep it alive, then when it actually gets deleted becomes undefined, right?
Well, it doesn't have to be. I mean, that's pretty similar to Linux file deletion, right? The file, the inode goes away, but the file's still there until the last accessor closes it, and then the file goes away. So that is not. So this is
that's one of the worst decisions POSIX people ever made. Like I'm
just saying that it's
gross.
Precedence for saying a resource doesn't go away till the last accessor closes it.
Well, if you think about it, if what we're saying is like the existence of a BAR keeps the bucket alive, then what that implies is after everything is gone except for the last BAR, the deletion of a BAR causes a bucket to go away. And that would be very surprising to a user, I think, to say, oh, I deleted my BAR and the bucket poofed, because nobody would expect that, right?
Of course, the preamble to all that is the BR is gone, and the delete and the retention policy is set to delete, and the last accessor has essentially logically closed it, right?
Maybe what you need is a third deletion policy. You could have a deletion policy of delete, a deletion policy of retain, and a deletion policy of like dangle for a while until the last accessor is
that's
gone.
Fair. There could be more nuances in the deletion policy for sure.
Yeah, but yeah, I think if the deletion policy says delete, that's what it should mean. And if you want another policy, which is delete when nobody else is pointing to me, or garbage collect me.
Yeah. I kind of like that idea of letting that be controlled through deletion policy. I think you get the best of both worlds doing that.
Yeah, the idea that the deletion of a BAR could cause an actual bucket to go away would be very surprising to a user, I think.
Yeah, because the user might not know the deletion policy is set to delete, right?
Yeah. They just know the name of it, and they know they had a reference to it, and they know they were using it, and they're done using it. And so they don't want to be responsible for accidentally deleting someone's potentially very valuable bucket just because they didn't need access to it anymore.
Well, yeah, I mean, it's a little bit weird because it's so valuable data, but the BR is already deleted, and the delete.
I know, yeah, that's why I like the black and white. When delete means delete.
Yeah. So in the case where retention policy is set to delete, BR1 is deleted, at that point your view is teardown begins, and at the end of the teardown, bucket 1 is gone, and the back end bucket is also gone.
Yeah, and any pods that were accessing it just start to see errors. And
BAR3 does what in that case? Is it pointing to nothing? Is it deleted?
Yeah, it would be pointing to nothing, and you could have a controller that could update its status that says it's now in a bad state.
I personally like that better than you saying Cozy should delete BAR3 because we didn't even create it. So I don't want Cozy to delete it.
No, you wouldn't delete the BARs. They would just go into a bad state.
Yeah, I'm okay with that.
So this whole thing is about so we want to make the bucket independent of the BR, and the current consensus is we're going to let if the deletion policy is set to dangle or if it's set to retain, it just hangs around. Is that what the current consensus is?
Yeah, but retain would mean that it will just live without any bucket requests attached to it, and it'll just live forever until an admin does something about it.
Yes.
And then delete would mean that the guy who created it gets to delete it when he deletes his object, regardless of who's using it.
Right.
And there could be a third policy that sort of implements some sort of a hang around as long as there's references, but that just makes me feel weird because of the potential for
delete when no access or something. But
no, why can't we always make that the default? You're saying there's a forced delete versus a normal delete.
Yeah.
And in the case of a forced delete, you don't care if someone's using it. In case of normal delete, you do.
Yes.
I mean, if someone wants to really force delete, we could they just go, admin can just go and remove the finalizer or something. And we always just, do a normal delete.
Admins are not supposed to mess with, admin should never have to mess with the finalizer. It's okay to give a knob to an admin in the form of a policy field that they can change. I would not want to tell an admin that they should be deleting a finalizer to
so we have the concept of a forced delete with pods. What's the difference between that and this? Oh, in that case, it just sends a SIG kill instead of a SIG int, I guess. SIG term. I think that just chooses the signal to send.
Yeah,
I'm trying to think. Yeah.
I don't like the idea that another namespace can keep my object hostage, right? I created something. I want to reclaim the space because it's eating into my quota or whatever. And if there's another namespace out there that happened to guess what my bucket name was or was told by someone, now I can't delete it.
You can still have the concept of allowed namespace and all that.
And Ben, that keeping your namespace hostage, like you said, you don't have control over it as the BR author anyway. You got retention policy through your bucket class. That was created by an admin. So unless you have a bucket class that gives you the retention policy you want, the user really doesn't have say on the bucket's retention.
Right, but in a normal greenfield scenario, delete is the one you would use because you want to create your buckets and delete your buckets and have this automated workflow.
The one the one you get is whatever is defined in the BC.
I'm not disputing that. I'm just saying that for the greenfield use case to be useful to people, delete you have to have a BC with delete on it.
Yeah.
Otherwise, you can never delete anything, and that's really weird in an automation environment.
Yep.
Right. Because you'll just end up leaking everything you create.
Yeah. Fair point. I agree. And I think maybe we want to change the KEP to make the default retention policy be delete like it is for dynamic PVs.
Yeah.
Now, what happens if your app in namespace 2 does want to adopt bucket 1 as well?
Yeah,
no matter what the life cycle of the app in namespace 1 is.
Hey guys, before we start that, I'm running out of time.
Oh yeah, I have to jump to another meeting.
Yeah, can we let's continue this on Thursday? I think we really started the right conversation today. I like this approach a lot, so we'll take it forward from there on Thursday. All right.
Okay.
Okay, bye.
Oh yeah, let me
Thank
try
you,
to.
everyone. Thank you, Jeff.